one? Okay, this one concrete for pre-stress concrete, for example. What is special about pre-stress concrete?
Provides earlier stress.
High early strain. Okay, in 3 days, for example. Okay, so we need to be able to do this kind of concrete, high early strain design. What else?
Slump test.
Slump test. High workabilities. This is a very high workability concrete. This is self-compacting concrete. Self-compacting concrete. We are testing what we call slump flow. Normally concrete we check workability by checking the slump, but this one is called slump flow. We check the diameter after we use the same equipment to measure the slump, bring it up. This one will go down and then we measure the diameter. Roughly, in this number, around 80 centimeter, almost flat down. Okay, 80 centimeter. From here you can see segregation or non-segregation. What is segregation? Very important wording, segregation. When you make your concrete, you don't want it to segregate. You don't want the heavy part to separate out of the weak part or the light part. You want them to look uniform and act uniformly. So you can look at the mix here, whether it has some segregation or not. Okay, so all the mix that we do in our design, no segregation. That's the first requirement. No segregation at all. That means we can get uniform materials. What else? This one? Anybody look familiar with this? Huh? Cube?
Strength.
Strength? No. Air entry in concrete. This one they check the air content in the concrete. In what application we put air into concrete? In what application? Where? Where?
Wide.
Void. Cool.
Sound insulation.
Sound insulation. You need a lot of void for sound insulation.
Chlorine change for degradability checking. Chlorination test.
We need void. We need air in. Is it cool? What is cool? In cold storage. In freezing and thawing condition, such as outside snowing, temperature under zero. In our country, we don't have snow, but we have the cold storage. Cold storage that they keep frozen product. Temperature going down to how much? Minus 40 degrees Celsius, minus 25 degrees Celsius. It's very cold, so you need special concrete. You need air, not like the one that we do in insulation. Insulation we need a lot of air. That is lightweight concrete, for example. But this one, the strength is similar to the normal concrete, not too low. Okay, but we need air. Okay. What else? This one, special concrete for repairing, for marine concrete, for example. Okay, so it's combination of concrete for seawater exposure, concrete for repairing. In this job, maybe we need high early strain, so we have to design for high early strain, marine concrete, repairing requirement. So we need a lot of requirements, so we have to design our material to meet the application. that we face. Okay, so sometimes it's not only one type of material, it's up to the application that you see. In this work here, above, they allow only 3 days to course for the repairing. That means we do this, we have to gain the strength back in 3 days. Only 3 days. Because operation is above, so they allow only 3 days. So the problem is, can we design material for repairing, for the marine environment, for high early strength? So we have to do all of those. This one is, what is this one called? Huh? Joy? Trimmy. Okay. What is this trimmy for? Maybe ball pie, for example. Maybe cast underwater, for example. Okay. We have to design special concrete for that. Okay. And this is for concrete for pumping. Okay, so first photo. Let me go quick now. Okay, the course outline that we will look at in this lecture will be, we look at the structure of concrete, we look at the strength of material, we look at the dimensional stability. What is the dimensional stabilities? What is this term here? Give me some example. Dimensional stability, we talk about like shrinkage.
No change after the casting.
We need the concrete to be stable in terms of the dimension, but our concrete always change according to temperature, okay, according to moisture, according to heat, blah blah blah. Okay, we talk about this dimensional stability. We look at the durabilities, we look at the proportioning concrete mix, we look at the some topics on advanced in concrete technology, and then we look at the premixed dry mortar. What is mortar? Okay. Fine aggregate, cement, water with no coarse aggregate. Very special. Anybody knows well about the dry mix mortar? Where do they use this mortar? Where? Is this concrete? Is this concrete? Is this a concrete?
Mortar.
Do I mean surface or do I mean inside? Okay. Outside here, this is a mortar. We call plastering mortar, not the concrete. Okay. Inside maybe the brick. Inside here, concrete, and then they put plastering mortar around to make to the shape for architectural look. So outside here, not the concrete, it's the plastering mortar. Okay, for tri-adhesive. Okay, for special mortar. Okay, we will learn about mortar in this class as well. Okay, we get more. I skip this one. This is the detail of each topics. Dimensional stability, we have dry shrinkage, we have creep, thermal shrinkage, elastic behavior, type of deformation and their significance. Then we look at durabilities, okay, deterioration by surface wear, by frost action, by fire, chemical reactions,